Hi dears, this is Raji. In order to answer questions related to transition elements, we should be familiar with the atomic number and electronic configuration of 3D, 4D and 5D series elements. How to memorize 3D and 4D series elements in the order we have discussed in the previous videos. Okay, I'll share the link of that videos also in the description box. You can just go through that. Okay. Yeah. In this video, we will be discussing a very simple method to recollect 5D series elements. And we will be discussing the questions also related to that. Okay. Yes. See this picture. So this is the simple sentence. By this you can memorize the 5D series elements easily. What is this one? Lieutenant Hanif Talwar wants Regiment Oasis to ignore Palestine, Australia and Hungary. So this is Lieutenant Hanif Talwar. He has a regiment Oasis. So many soldiers are there with him. They are going to attack somewhere. Okay, so Hanif Talwar wants his army not to attack Palestine, Australia and Hungary. He wants to ignore these countries. Okay, we don't know what's the reason. Okay, yes. Read this sentence 2-3 times so that you can retain this in your memory. Okay, Now, using this, how can we recollect these elements? Lieutenant. You can find another spelling for lieutenant also. But in order to memorize Lanthanam, this is convenient for us. Okay. So lieutenant, you will have to remember Lanthanam. Hanif, that is Hafnium. Okay. Talwar, that is Tantalum. Ta. Wants, tungsten. Okay. W. Regiment, Re, that is rhenium. Oasis, that is osmium. That is the name of the regiment. Okay. Osmium. To ignore. Ignore is Ir. Iridium. Okay. And Palestine, easy to remember, that is platinum. Australia, that is gold. Au. And Hungary, that is mercury. Will you memorize this? You should. Okay. Yes. Memorizing the shortcut, we are going to write all the elements of 5D series in the order. Write along with me. What is that sentence? Lieutenant. So we will write Lanthanum. Hanif, that is hafnium. Talwar, that is tantalum. Wants, W, tungsten. His regiment Oasis. Regiment is rhenium. Oasis osmium. To ignore. Ignore is Ir. Right? No? Iridium. Palestine, Australia and Hungary. Right? No? So Palestine is platinum. Australia is gold and Hg is mercury. Now, how to find out the atomic number of lanthanum? For that, you should have an idea about the first element present in the 3D series. We have already discussed about that. Which is that element? That is scandium. Atomic number is 21. Then, in order to get the atomic number of the first element of 4D series, we will have to add 18 to that. So, you will be getting yttrium. That is 39. Now, in order to get the atomic number of the first element of 5D series, again we will add 18 to 39. So you will be getting the atomic number 57. That is nothing but lanthanum. Easy. Okay. So we got the atomic number of lanthanum, that is 57. Then what will be the atomic number of hafnium? We will think 58, 59 and so on. It's wrong. Okay. Remember, after lanthanum, which element should be coming? That is cerium. Okay. Cerium is having atomic number 58. Reason is that after lanthanum, the f orbital start filling. Okay. So here, the one electron will be present in the f subshell until all the f orbitals are completely occupied. That is, when the configuration will become F14, the electrons will be added to these elements. So remember cerium to lutetium. Okay, all these are F block elements. So actually the elements from cerium to lutetium having atomic number 58 to 71. should be coming in between lanthanum and hafnium. Correct, no? But that will make the table much more elongated. So in order to make it more compact, we are keeping these elements at the bottom of the periodic table. Okay. So remember, the atomic number of hafnium is not 58. So in between lanthanum and hafnium, 14 elements will be coming. That are lanthanoids, we will say. Okay. So how to get the atomic number of hafnium? We will have to add 14 plus 1 to 57. Okay. Then only we will be getting the atomic number. Atomic number of hafnium is 72. Tantalum 73. Tungsten 74. Rhenium 75. Osmium 76. Iridium 77. Platinum 78. Gold 79 and mercury 80. We got that. Now see this one. Using the trick, we have written all the elements and their atomic number also here. Okay. Now we are going to write the electronic configuration. Only for lanthanum, let's write the complete electronic configuration. Up to 5p6, 54 electrons will be present in the inner shell. That electrons won't be participating in the chemical reaction. We would like to know the electronic configuration of the outer shell only. That is, in 6s and 5d. See, this is the electronic configuration of the inert gas xenon. Okay. In the short form, the same configuration, we are writing it as xenon 54, 6s2, 5d1. Okay, so remember, in all these elements, 6s also, 5d also will be present. See, to save time, I have written the electronic configuration of all these elements. Remember, xenon 54 will be present, 5d and 6s also will be present. And from hafnium onwards, you will have to write 4 of 14 also. Why? Because in between lanthanum and hafnium, 14 elements will be coming, or the 4 of subshell will be completely occupied. In order to answer question, you will have to memorize how many electrons are present in the D subshell and S subshell also. Okay. For that there is an easy trick. How to memorize? Remember, platinum and gold both are precious metals, right? No? So both of them will be having one electron in the S subshell. Understood? So 6s1 and 6s1 in the case of platinum and gold. All other elements will be having 2 electrons in the S subshell. Remembering d orbital is little difficult. Okay. So this is the easy method. So platinum and gold are more precious. We are giving more importance to that. Both of them will be occupying 1 electron in the S subshell. Others will be having 2 electron in the S subshell. You know the atomic number of the element. Then easily you can find out the number of electron in the D subshell. In the case of lanthanum, how many electrons will be present in the D subshell? Calculate it. Atomic number is 57. 54 plus 2, it is 56. Then remaining 1 electron will be present in the D subshell. Okay. To answer questions, we need only the outer electronic configuration. Now, atomic number of hafnium is 72. 54 plus 14, 68 is present. 8 plus 2, 70. Now, 2 electrons will be present in the D subshell. Correct? No? Easily you can find it out. Okay. Memorizing D orbital is difficult. Okay. But memorizing S orbital is easy. Only platinum and gold will be having 1 electron in this S subshell. All others will be having 2 electrons. So in the same way, I have written the electronic configuration of other elements also. You can check it. Okay, it's very easy, right? Yes. Now see this question. Which of the following will have a magnetic moment of 2.83 Bohr magneton? How can you find out the magnetic moment? The magnetic moment mu will be equal to root of n into n plus 2. This is the formula, okay, where n is the number of unpaired electrons or single electrons present in the orbital. So if you are getting this kind of a question, quickly we will have to recollect the atomic number and electronic configuration also. See, all these are 5D series elements. Using the trick, we can write the elements in the order and quickly we can write the atomic number also. what is the atomic number of hafnium? Hafnium will be 72. Okay, the nearest inert gas configuration will be xenon 54. Okay, then 4f, 5d and 6s subshell also will be present. Okay, yeah, now hafnium will be having 2 electrons in the S subshell. Only gold and platinum will be having 1 electron in the S subshell. Now, how many electrons will be present in the D subshell? Yeah, that will be 68 plus 270. Yeah, then 2 electrons will be present. This is the electronic configuration of hafnium. If it is hafnium plus 4, 2 electrons will be missing from 6s and then 2 electrons will be missing from 5d. So, there is no unpaired electron. All the electrons which are present in the f orbital will be paired. Okay, yeah. So, if there is no unpaired electron, what will be the magnetic moment? Magnetic moment mu will be equal to 0. This is not the answer. Now, see the next one. What is the atomic number of tungsten? 74. Okay. Nearest inert gas configuration is xenon 54. Then 4f will be there, 5d will be there, 6s also will be present. And 2 electrons will be present in the 6s subshell. 14 will be present in F subshell. So together, this is 68 plus 270. Then 4 electrons will be present in the D subshell. 5d4 configuration. This is the electronic configuration of tungsten. But they are asking tungsten plus 2. So 2 electrons are missing. Now write and see how many electrons will be present in the D subshell. 4 electrons will be present. That means 4 unpaired electrons will be present. So calculate the magnetic moment. Mu will be equal to root of 4 into 4 plus 2. That will be equal to root of 24. It is nearly equal to root 25. Square root of 25 will be 5. So it will be slightly less than that. The value will be almost 4.89. We need 2.83. This is not the answer. Now see this one, gold. Gold will be having the atomic number of 79. So write and see what will be the electronic configuration. Xenon 54. 4f14, 5d will be there, 6s also will be present. As it is gold, okay, how many electrons will be present in the S subshell? 1 electron. Okay, 54 plus 14, together it will become 68, plus 1, 69. How many electrons are present in the D subshell? 10 electrons. But they are asking, gold plus 3. So, 1 electron will be missing from the S subshell. Then 2 will be missing from the D subshell. Okay, so what will be the configuration? 5d8. Write and see. What will be the number of unpaired electron? 2 electrons will be present. Okay, so calculate the magnetic moment. Root of n into n plus 2. 2 into 2 plus 2 is 4. Okay, so that will be equal to root 8. What is the square root of 9? That will be 3. So this value of root 8 will be slightly less than 3. So what's the value? That is 2.83 Bohr magneton. This is the answer. Okay. Now what will happen to iridium also you check? Atomic number of iridium will be 77. So electronic configuration xenon 54. Then 4f14 will be present, 5d will be present and 6s also will be present. 2 electrons will be present in the S subshell. Then number of electrons present in the D orbital will be 7. Okay. Yes. Now see, they are asking iridium plus 2. Electrons from the S subshell will be missing. So how many unpaired electrons will be there? The configuration will be 5d7. Write and see. 1, 2, 3, 4, 5, 6 and then 7. 3 unpaired electrons will be present. So that will be equal to root of 3 into 3 plus 2. So that will be equal to 3 into 5, that is root 15. Square root of 16 will be 4. Okay, so this value will be slightly less than that. 3 point something you will be getting. The exact value will be 3.87. Okay, but that is not the answer. The answer is the third one, C. Got it? If you could recollect 4D and 5D series elements, you can answer a lot of questions related to lanthanide contraction also. We will be discussing that concept in the next video. Please subscribe for more videos. Thanks for watching. See you in the next video.